All right. Oops, sorry. There's a few things I should probably just mention in case you didn't see the announcement. So today, the second section after this, I will stay here. I think one of the TA will be here. We'll be here to help you to, for some of you, most of you probably already done for homework 3. If you still have question, we'll get to that today. Today, I'm not going to do the participation credit. So I'm going to just convert it to a regular class. And the source code, I'm actually provided, I haven't uploaded to the GitHub. I will do that after the due date of homework assignment number 3, which is tonight. Because some of the code actually involve the homework assignment number 3. So what we have been doing last Friday as well today is actually help you to prepare for both homework assignment number 5 and homework assignment number 6. So last Friday, what we did was try to learn how to use a data structure called vector, and also how do we understand the counterpart about the same mechanism in Json. So essentially, you know the array in JSON, and then you know the array in C++, then you can actually do bilingual. You can actually switch back and forth. So that was the lecture that we did last week. And that will be useful, by the way, for both your homework assignment number 5 and homework assignment number 6, all right? And possibly for your final project as well. While the other thing which I forgot to say last time is that for homework assignment number 5 and 6, you're going to work for 3 to 4 students, just exactly what you're going to do for your final project. So what you need to do for your final project is based on your idea that you developed during the midterm exam. And among 3 or 4 of you, I actually put some comments about some of your innovation I really like. I mean, for example, one of the ideas I really like, I have to say that I forgot the name of the student, but that was the best idea I saw from you guys, is essentially the bike and the car, they will communicate. And such that the bike will actually know that I will be hit. So I will move myself to attach essentially to the car. So when the car moves, it basically, you can think about, you only got a couple seconds, but that's actually probably enough for the bike or motorcycle to be attached physically to the car. And then they actually move together. That will reduce dramatically the impact and maybe no impact at all. So that's actually what I call space conservation, because essentially you look at the space between the motorcycle and the car, and then you reduce that. And that actually, to me, is very innovative. I don't think anybody in the world actually thought about that idea, to be honest with you. And I think it's a great idea. If you think about that, all the car is autonomous. And the thing is that they actually be able to use the space wisely to avoid, you still have to hit it. But the thing is that you actually think about, I'm actually going your way to do that. So that is actually possible with a software-driven car. I think that's wonderful. So I want you to actually start thinking while you're working on 5 and 6, you also start to communicate what you have done for your midterm exam. And then I want you to actually realize that design you have, you pick one among 3 or 4 of you, and then you basically just make sure programming, and don't try to program big. You don't have to program real car. It's really just object and GPS location or whatever you can represent. As long as you can represent the concept, this is good. Yes. Yeah, homework 6, I will announce, I will probably release today. About the thing is that homework 6, I have to related to what I'm doing. I will explain to you why. But the final project, you just need to do a demo and then present a recording about what you have done. Okay. All right. So that's actually a final project. But now I'm going to get into what we are doing today instead of last Friday. So last Friday, we basically just talked about, okay, how can you record the address or the location of an object at what time? So essentially using this kind of core object to actually record that because of the vector. So today we're going to talk about the real part about object mobility. So by the way, if you haven't noticed that we have been talking about object mobility, meaning that an object can actually move around. So in homework assignment number 5, we want to do is you move Little Red Riding Hood from one location to the other. But for homework assignment number 6, we're actually moving a Wordle game, the partial Wordle game. You already solved the problem only partially. You provide 3 answers to that. So you basically have to record that. And then that is a game that you can actually move around from one group to the other, from one student to the other. That's what we want to do. So that's why both homework 5 and 6, they're using the concept of object mobility, which is a concept that's actually so useful in a lot of practical application. And yet you have to think about the simplest way you can actually do the programming so you can actually extend it to the most complicated cases. Okay, so I'm going to show you, whenever I do object mobility, I always started with what file? That's the JSON RPC file. So I'm actually going to show you this file first. Okay, so this file is basically used to create the interface among different parties that involve this object movement. So this file is the input for the, I call it, you will actually get it tonight from the GitHub, which is ecs36b underscore HW5 JSON. And you can see that the first function that's in the, okay, by the way, up to this point, you already have see the file. I forgot is homework assignment number 3. Probably I have give you this or one of the early version. You actually see this part, which is I declare a JSON RPC to do dump to JSON. So dump to JSON is you try to retrieve the content from object remotely. But now I'm actually adding 2 more functions. That this 2 function is essentially enable us to not just access the remote object, but actually move that remote object in the C++ form to a local C++ object. So that's why we have, let's go through the first function is called move. So what is move? Move actually take 4 arguments. Okay, in this example, take 4 arguments. The version you will get tonight, there is a 5 argument, which I will show you the little bit difference later. But essentially what it is that, of course, the name is called move. I want to move something. And then the action, you have to say what action is actually move object. And then location means that where is the location I want to move this object. So I'm actually using in my implementation, I'm using JV time, but I use the JSON representation of JV time to represent that location. So that location indicates where I want to move this object. And the second part is that, well, when I move, I need to know what is the class of the object I need to move. By the way, I might not need to know what's the object identity, but I need to know the class. Why? Because I need a class in order to create an empty object. So you can actually using the force argument, which is the JSON object. So what is a JSON object? JSON object is the result of dump to JSON. If you have a C++ object, what does that mean? When you call the function dump to JSON, you actually convert that C++ object into a non-structured representation of the object, which is JSON. And the thing is that for me to revert the process to recreate the C++ object, I have to know the class name, right? I have to know whether this is a thing, or this is a person, or this is whatever. So I can actually be able to call the right version of the function or the right version of virtual function to actually do that part, to do the JSON to object. So that's why move actually have a for argument. So you can think about, let me actually show you what move is, then I will explain to you the detail. Okay, this is the object. So I'm going to, let me actually show you the client first. How do I actually call this JSON RPC? So this is my HW5 client. Let me show you how I actually call it. This is actually pretty similar to what you have seen before. So I create a bunch of GPS location. My 3 favorite places in the whole world: Costco, IKEA, and this classroom. Okay, that's pretty much all my favorite places in the whole world. So I create this person called John. And that's basically he's in Woodland right now. Okay, so this is the part I'm actually going to do this RPC call. You have seen this earlier under shadow thing.cpp, but I'm going to use it in a different context. So I basically, again, I create a server, HTTP server. I provide that URL, HTTP client, so I can actually communicate with create a server. And then this is interesting. Here I'm actually call the function. I call my client.move, and take a for argument. Let's actually look at what are those for arguments. Let's go back to ecs36b, hw5.json. Okay. Oh, sorry. Let me actually move up a little bit. Okay, great. So this is the function I declare using JSON RPC, and the JSON RPC stub is going to use that specification on the top to generate the code for both HW5 client.h and HW5 server.h, and that code will enable me to directly call. What is my client? My client was created over here. You see that? I'm actually create HW5 client. This piece of code was generated. I just need to call it this way. And then after I got to that, I said my client.move, and it takes how many argument over here? 1, 2, 3, 4. And this is a 1, 2, 3, 4. Okay, 1, 2, 3, 4. So, but however, the order is a little bit different. You see that my first is a move, which is corresponding to action object. That's fine. My second one is actually the class ID, which is a person, because now I want to move a person. So now the class ID becomes the second one. And the third one is actually the JSON object, is the John dump to JSON. And then that will create a JSON itself. And then I just basically present to style string and convert it to a string. So that became the person I'm going to send it to remote. And the number 4 is location. So why is the order of this is different by this? Is the JSON RPC stub, they look at the order of this 4 argument alphabetically. So that's why A is the first, and C is the second, J is the third, and L is the fourth. Okay, yeah. Well, in the JSON RPC, I can only pass as a string. So I cannot, it doesn't provide the facility to directly use in JSON. The JSON RPC, everything is essentially, I can still have the same as a string. So the whole structure is a JSON being sent. But the thing is, as one of the element, it still has to be a string. Yeah, that's why I'm actually sending that as a JSON string. That's why I use this toStyle string. Okay, so now let's actually take a look at this again. So I have a move with 4 arguments. The action is called move. The class ID is person, and the next one is JSON object, which is the object I want to move. You look at what I did. John is a person I want to move. John is here. This is the John is a person object, and he is in Woodland at that time. And dump to JSON, basically create a JSON, and then I toStyle string converted to a string representation of the JSON. And where do I want to move? I want to move John from Woodland to this classroom. That's why I want to provide the address about where I'm moving to. That's GPS TLC underscore UC Davis. That's the address. Again, I do a dump to JSON. I convert it to a JSON format, and then to convert to a string format. I always play this trick. C++ to JSON and JSON to string, because string is the universal way I can actually pass around with the RPC protocol. And with this 4 protocol, it allows me to connect to the server side. Okay. Yes.
The move function defined in like my client or homocard client.h?
Yes. Yes. So let's take a look at this. This code is generated by JSON RPC stub. And if you look at the client, it has one of the function is move. And take action, class ID, JSON object, and location. That's actually, this part of the code is generated. Let me actually show you how this piece of code is generated from here to here. This piece of code is generated. You can see that essentially it's actually doing a JSON encoding. It's actually have a JSON value P, and it takes action to that action parameter, class ID to that class ID, JSON object to that JSON object, and putting all of them into the perspective, and then you can send it over there.
Also, it's doing for the 4 parameters, not just the location. Because for John, we're just moving his location, right?
Right.
What we call the move function.
Right.
So what's it doing with the other parameters?
Okay, so essentially, okay, that's a good question. You're asking, why do we need anything else? Because we want to move the location to the other server. Well, in my design, it doesn't have to be this way. In my design, you have to look at the server-side code, because I don't have a mechanism to know which server actually represent which location. Unless I have some service, I will know now this particular program is running at this service. But that is actually part of the logic of the server side. The first thing the server is going to do is when I receive this request, I want to see the location you try to move in is actually the same as my current location. If that's true, then I will let the mobility to take place successfully. If not, I'm going to return the error message. Yeah. Okay. Any other question? Great. Okay. So this is essentially how this is being done. Okay. You actually encode it and then just send it. This is the mesa, by the way. This is the place that you really make the call, mesa. Oh, sorry. What did I done?
You added a at the beginning.
Yeah, that's okay. Don't worry. I will just make a claim. I'm glad that piece of code was generated, so I don't have to worry about anything. I will just regenerate again, because by the way, if you don't realize, that code was generated by this line in your make file. JSON RPC stub, and look at that RPC spec file, and then you have a server side, you have a client side. Okay, and then that's the okay. So now let's actually look at the server side. Okay, you know the client side. By the way, any question with the client side? So just take that and then make that call. So let's look at the server side. Okay, in the server side, everything looks similar, except now we go to the move. Let's look at how the move function is working out. By the way, this is essentially encoded in a way that it will only support moving a particular class called person, but if you want to move any class, you just change that part of the code. So the first thing I did is essentially I check whether the class ID is person or not, because right now I only support moving of a person. Okay, and by the way, this particle, I remove a few lines because it's actually related to homework 3, but I will explain what did I move. And if everything is okay, what I did is I check the address. So what I did, okay, let me just show you. This is the trick I did. I go to the main function on the button. In my main program, I basically set my location. I said the process is here. What's the here is actually GPS TLC UC Davis. That's the address where we're in right now. Okay, so I set process ID, process here to be exactly the GPS location at where we are in the classroom. Okay, so that's basically process here. So I set it up there. And that's how I actually can do this. When I do this, I just say, if process here as object is a GPS object, whether that's actually the same as the incoming. So what do I do incoming? What is incoming? I take a for object, action, class ID, JSON object, location, that's exactly the same. But what I did is I actually create a GPS C++ object called incoming, and then I do incoming.json to object location. So I converted the location object also to a C++ object. In fact, here, the original code looks like this. The original code looks like this. Let me actually tell you that. Should be process here and the incoming, because they are both GPS object. If they're the same. Well, however, I realized that in order to do that, I need to have operator overloading, because both of them are GPS DD. I need to do operator overloading. So you can actually do this, but you must provide operator overloading, the template that you can actually supply that. If you don't have operator overloading, then you better do something like this. You dump the to JSON object, you compare their JSON object, whether they're the same or not. Okay, so that's basically the difference. So I compare the difference. If it's not different, then I'm going to say, hey, I actually don't have, this is the wrong location, you contact the wrong port number or IP address. I'm sorry, I don't allow you to move here. Okay, so in case you actually move correctly, this is the way you're going to do. So look at what I did. I actually converted to call this person. This person is actually the new object I created. By the way, I have in this program, I have a person map. I have a two map to host all the objects. One is called thin map, one is called person map. So I have this two map, but I didn't have object ID. So that's why the other version, I do have a object ID, so I can use the map here. But if I don't have the person ID, what I just did is I take the JSON object. What is the JSON object? Let me actually go back to the client. Okay, look at this is the JSON object. This line is John.dump to JSON and to style string. This actually converted to to this variable, JSON object. And what I did, you see, is just the reverse pass. When you generate that using dump to object, I'm using JSON to object to revert it back to the person. So this person became the same person as John over there. So by doing this, you actually allow yourself to actually move an object from one location to the other, basically from one server to the other. I do want to say something which you might have noticed, but I want to tell you that this part is really, I want to get your attention. So I have one function I define called move. In a realistic system, I also need to have the other function called copy. So for most of the realistic system, we usually have both functions. One is move, one is what? One is copy. So can someone tell me what do you think is the difference between object mobility and object copying? What will be the difference?
Copies of the object, one copy of the object.
Exactly. So basically, move means I'm going to destroy the original copy. I'm going to nullify, so you only got one copy, and that copy will move to a different location. And copying, as you said, has more than one copy. When I move to the other server, when I move from Woodland to UC Davis, TLC, then essentially I have two objects. And the thing is that these two objects, they are both still exist. So they both can do interaction. They both can actually purchase transaction. They both can do a lot of interesting stuff. Let me ask you a question. Which notion do you think is more realistic or more useful? Copying, do you think that when we do object mobility, should we always do object copying or should we do object mobility? If you think about a person.
Sorry, could you ask the question one more time?
So I have two options. One option is called object mobility, means that I move from one place to the other and the original object from the original location needs to be purged out. So in the whole world, I only have one copy of that object called person John or person Amen. The other option is that I actually can make a copy. That object, it still exists in Woodland when I move that object to UC Davis. It's a different option.
We should remove the object because a person cannot exist at two locations. I mean, in this universe at least, how could I be at UC Davis and Woodland at the same time?
Maybe for safety and security reasons, you want to keep the old copy of the object, even though that will be very redundant. Because you're not going to really do anything.
Okay, for redundancy, that's another thing, right? To copy. But can you think about some real world situation that you actually prefer to have both copy? Yeah.
Like if you were to go to a hospital, I would assume that if say you go to a hospital in San Francisco and then you come to like you move, you would want to be able to access the same records, I guess. So you make copies of the data that you have.
Yeah, when you move the object, you move all the existing records at the same time.
Or you would want to copy from that. Like, you don't want to destroy the data that you have.
I mean, so if there is a case when one place is inside of the other place, there's this UC Davis and Davis. So if I were to go to the UC Davis, I would be both in Davis and UC Davis at the same time. And in this case, this person would be in both places at the same time.
Yes.
Like a weird case, but like if you're, for some reason, if you're also, like if you're in Davis, but if you like log on to like a game and then then you would be two copies of yourself.
In fact, I would say the reason I want to kind of ask you this question, this is actually a fun question. I could have asked this question for the midterm exam, maybe you would like this more. Because both cases has its merit. If I want to make sure you only have a one physical person, as Eamon pointed out, you should make sure you only present only once. But there are activity that we actually want to have simultaneously multiple agents of ourselves in different places. They will interact with the real world, and such that at one point you will see that when you copy the object, you will not just copy the object, but the content of the object will continue evolve into different versions. I mean, for example, you mentioned about the video game, right? And let me actually give you a real world example, which might be related to that. You might know, you heard about the term of data center, right? Anybody familiar with data center? So Facebook, for example, as a company, right now I think they have 5. They used to have 4 data centers. I know one of them is in Sweden, one of them East Coast, one of them West Coast, and the other one is probably in Singapore. So they essentially has 4 different data centers to host the data. So essentially, when you actually connect to the network, you interact your own data, or you interact somebody else, your friend's data, and your friend's data is actually going to be in certain location, it depending on your network performance. So if I'm in Asia, then probably I prefer my profile or my related image will be moved to Singapore. So you will be able to connect to that easier, much faster. But on the other hand, you have friends in Europe, and therefore some of your content need to be actually hosted in Sweden. So people from Germany or Spain or even Egypt, they can actually connect to the Swedish meatball. I mean, I always use Swedish meatball as an example. And the thing is that you will simultaneously interact. So essentially, you have what I call a digital twin that's actually happening in both Sweden and Singapore to actually interact. And then people click like, people share, and you also add content. The thing is that this 2 copy at some point is going to be desynchronized. This 2 copy is not going to be the same all the time because it's too expensive to actually make sure. But it actually serves a purpose to let the distributed object be able to save some network bandwidth or actually be able to present at the same time in 2 different locations and then be able to do that. Okay, so you can actually think about a lot of this example in industry. They try to duplicate the object in a way, they move the object, but on the other hand, this object are still evolved. But then they actually be able to what I call synchronization to actually at some point, I will be able to see. I mean, the same thing for your bank record. Anybody believe that your bank only have one single location to keep your financial information? That might be actually unsafe. You want to have a duplicate information to allow you quickly access your money, essentially. And the thing is that at the end of the day, they try to do some synchronization. So that's why the difference between move I actually probably should do this. Let me actually tell you the difference here. I have one function called move. And I probably need another function called copy. In a realistic system, you always have this two functions. Just show you that. Okay, so since you have this two function, then you actually need the third function that I define here called locate. So what is a locate? Because you create so many copies, or you actually only have one copy, but you don't know where it is. It's actually move around. So what you want to do is you need to have a function called locate and try to go to every single location that you know possibly this object might be there. And over there, you try to actually locate, search for a location, search for the class ID and object ID, and also look for what is some of the content you want to match. For example, over here, the JSON object probably require some of the name or some of the like your personal information for you to do this kind of match. Okay, so with both locate, copy, and move, you can actually make a really powerful object mobility. Okay, that's the bad news for you, probably for homework assignment number 5 or homework assignment number 6. But for homework assignment number 5 and 6, you don't need to worry about this too. Okay, I just want to tell you that's a more realistic way of doing this. For homework assignment number 5 and 6, you really just need to worry about, I'm going to get rid of this as well. This is what you need to worry about, is move. Okay, you just need to worry about one function that allow you to do that, but you know that's is not going to be too useful. In realistic situation, you need the other two. But the thing is that for you, if you can actually move Little Red Riding Hood, Big Back Wolf, the Y or whatever to one location to the other location, that will be a really good starting point. Yes.
So if we had multiple functions, it would be in an array. That's why you square brackets, right?
Right, exactly. See, this is the array, JSON array, right? If you have a more than one function, just adding that. Let me actually put it back.
I didn't realize it was an array until I actually saw the square brackets. In the code, is there anything that indicates that it's a JSON array, not just the JSON, but
So this is the, let me actually specify. This is a JSON. Let me actually make sure I'm having this okay. No. So first, let's talk about JSON syntax. In JSON syntax, if you have a bracket, that means it's array. And it's array of something, it will be separated by the comma. You have a comma to separate that. That became an array. But you're asking in the program, how do I know it's an array, right? So that was the program I think I did last time, but I can bring it up to core.cpp. So in the JSON, you can actually say is array, meaning that whether the JSON object or JSON value you're actually swallowing, is that an array or not? You can use this function is array. So in case you missed it, this is the way I have this function last time. Wait a minute. I lost that. Yeah, here. You see that this is essentially the encoding that I showed the example about checkpoint. The checkpoint, one of this is starting with a data column, this one, and then this is array. So that's why when you have this, then I'm expecting this one is an array or not. I check if this array is true, then I'm actually going to use this iteration to actually go over. That's how I have to check. Okay, just remind you in case you didn't get it last time. The main difference between C++ and JSON is that C++, the type of the object or the variable is determined at compiler time. So as a programmer, you rely on the compiler before you even run the program. It's already determined what kind of type. If it's an array, it's an array by the compiler. If it's an object, it's an object by the compiler. But JSON is different. JSON is so flexible. It is really another paradigm for us to make a powerful thing. Is that it's not determined by compiler. It's actually determined by runtime. At the time you receive this JSON, that's why we call it non-structure. Non-structure means that it doesn't have a fixed format, and therefore compiler cannot do anything to your JSON object. The compiler can also only guarantee the basic syntax. Therefore, I have to rely on runtime. So that's why you see that at runtime, I have to check whether this JSON object is null, is an object, or is an array, or is an integer, or is whatever. So that's why it's two style programming. Mentally, we have to separate this. We have to deal with this C++ object. No worry, it's already done. I can just call it, use it. But as long as you touch the JSON, then essentially you have to remember to check. Don't assume. That is, when you receive something, don't assume it actually looks like this. Okay, this is the we expect it should look like this, but once you receive the JSON, the other side is some how do I say that, reckless programmer or whatever sysadmin, they actually didn't produce exactly the same format, which I actually seen so many times in my limited experience. And the thing is that this kind of check really helped me to actually digest whatever information I'm receiving. How do I do that properly? Okay, so this is the code I look at last time. It's actually a very good example about how you can actually bridge this two world using a programming language like C++. Okay. Any question? Okay, so I actually show you both the RPC stuff, the specification, the client side and the server side. I will actually upload the link tonight at midnight, so you can actually take a look and play around with it. And then Wednesday, I'm actually going to go for both homework 5 and homework 6. Okay, so you cannot, by the way, you cannot make it, it is going to be recorded. Hopefully, one of your team member will be able to make it on on Wednesday, but the rest of you, I don't know, maybe I only have like one student here in the room on Wednesday. I'm not expecting a lot of people here, by the way, but I will record it. But I wish all of you have a really joyful Thanksgiving, okay? All right, so I will stay here for your homework assignment number 3 and 4.